You can just drop it anywhere, and if you can compile it, then LVGL is integrated. Once it's running, it will give you a buffer where the image is rendered, and you can decide how to send it to the display. That's all what you need to do for integration.
On this episode of Embedded Insiders, Rich and Vin sit down with Gabor Kisvamosi, the founder and CEO of LVGL, to discuss the open-source embedded light and versatile graphics library designed to support both elaborate and simple UI design. Next, Rich and Axel Sikora, chairman of the Embedded World Technical Committee, discuss some highlights of the upcoming Embedded World event. But first, we're giving you a glimpse into what embedded computing design has planned for the quickly approaching 2026 Embedded World Exhibition and Conference in Nuremberg, Germany.
Hello, everybody. Welcome to another episode of Embedded Insiders Podcast. I'm Ken Briota, Editor-in-Chief of Embedded Computing Design, and I'm here with Tiara Oliver, our Assistant Managing Editor here at Embedded Computing Design, and we're going to talk about Embedded World, which is, shockingly, next week. Hi, Tiara.
Hi, Ken. How are you?
I am all right. How about you?
I'm good.
Yeah, next week we're headed off to Nuremberg. This will be your first trip to Embedded World, is that right?
Yes, it will. Very excited.
Yeah, it should be a lot of fun. It's a great show. We're going to see all sorts of cool tech and have just a million meetings. I don't know if you've looked at the calendar recently, but it's vast.
Yes, it is packed.
What are you looking forward to at Embedded World in particular?
Really just getting out on the show floor and seeing everyone, shooting content with different companies for the first time. So that'll be fun to be behind the camera and
You're going to be posting a bunch of stuff direct to YouTube, right?
yes.
That's very cool. That's going to be really, really fun. I'm excited about our podcast booth, which is also new this year. We're doing a bunch of live recorded podcast segments here for Embedded Insiders and Embedded Executive that we're going to be recording live and from the show floor. That should be really, really fun. Rich and I are going to be doing a ton of interviews. It should be a good time.
Yeah, I'm excited to see that too.
Of course, our Dev Kit Zone is back again for its well, I guess this will be the third Embedded World because we've had it at Embedded World North America and last year's Embedded World Germany. So this will be the third iteration of the Dev Zone, which is very fun. I love the Dev Zone. Us being able to check out all those boards, handle them. We're going to be making videos about them that folks can see on YouTube. Yeah, there's going to be a lot to see and a lot going on as always in Embedded World, but we're going to be having a great time.
Yes, and we've just posted our Best in Show nominees last week, so everyone can go online and check those out. And then the week of the show, I believe about a week from this podcast being posted, we'll have our winners and nominees.
Yeah, the Best in Show awards sort of reception that we do on the Monday night right before the show opens is always such a good time. We get up there, we announce all the awards, we make a big to do about it because it's a big deal. You know, the competition was tough this year. Lots of good tech. And it was a hard pull to get some of the. So we had some big debates in the judging room about who was going to get on the podium, as it were.
Yeah, I think every year we get either more entries or just more companies jumping into the competition. And yeah, I was on that call while you guys were making those decisions, and it was definitely something that seems very, very tough.
Yeah, we had a bunch of new companies. You're right. This time that I don't think have ever entered before, which is great to see. You know, it's important that's part of the purpose of an awards program like this is to drive innovation and raise the profile of those newer companies that are trying to break through.
Yeah, for sure.
We said we're doing a ton of meetings, ton of podcasting, ton of video, as we always do. You should, if you're listening to this on your favorite podcasting platform, thank you so much for subscribing. But you should pop over to YouTube, where Tierra's been doing a ton of video podcasting, and we're going to have a lot of that happening on YouTube from Embedded World too. A lot of video, a lot of news coverage. Tierra is going to be going to all the keynotes and press conferences and everything else that we could get her into while we're there.
Yes.
I hope your German's brushed up.
Still working on it, but I think I'll be good. Fingers crossed.
I think you'll be fine. I think you'll be fine. Do you have any particular sort of topic areas that you're excited to find out more about while we're there? Are you looking to dig your fingers into power controllers or something else?
I mean, I know AI is going to be a big topic, so I think I'm interested in that, but interested in seeing, a different angle that companies can present their products or topics, because I feel like AI is obviously it's talked about everywhere and everyone's incorporating it into their products. So I just want to see if it's out there. I want to see what different angle some of the companies are going to be taking using it. And
Yeah.
then I'm also always interested in like the environmental and sustainable efforts that companies are going into. So I think those will be some of my top two topics, but there'll probably be more that surprise me once I get there.
Oh, for sure. There's always surprises to be found.
Yes.
I'm going to be writing up I'm going to be looking all over the place for different through lines and trends. And, I sort of always use these big tentpole events for the industry to sort of look and see what people are talking about. And you'll be able to read about that after the show. And if you see me at the show, make sure you flag me down, because I want to hear what you've been hearing too out there.
Yes. I feel like everyone just has to stay tuned, stay glued to our site if you can, on our YouTube, everything, because we'll be releasing so much content, not only the week of, but the week after is when a lot of those podcasts will be posted as well. So we'll have
Yeah.
content for days.
Absolutely. And thank you all for listening and for joining us. We'll see you all real soon.
Yep. See you in Nuremberg. Now, here's Rich, Vin, and Gabor Kisvamosi of LVGL.
Good afternoon, and welcome to Dev Talk with Rich and Vin. I'm Rich, the guy there with the Porsche sweatshirt. What's up with the Porsche sweatshirt, Vin?
I drive a Porsche. I have a little Boxster that I love driving around. It's a lot of fun. And when Dominic was a baby, I could put him in the front seat because I had the Porsche child restraint system, which disabled the airbag. And Gail was always jealous because he was rear facing in the front seat with me and I could interact with him. And in her car, he was rear facing in the back. And she had this labyrinth of mirrors just to see his face. So,
is that legal, putting a car seat in the front seat?
Well, with the Porsche child restraint system, you plug it in and it disables the airbag. And that's the only reason why you can't have it in the front seat is the airbag.
Okay,
So,
I'll buy that. Anyway, how you doing?
see, sometimes technology can really enhance our lives and sometimes it can't. So
Yes, that is very true. So what's technology
Yes.
du jour?
Well, we recently had the webinar on HMI development with Renesas, and I thought it was a pretty good one. I'm a little biased because I was on it, but with our guest who was speaking. But I thought we would continue this conversation because, you and I are old enough to remember that when you had to create a UI, every bit was programmed separately, whether it was switches and lights or whether it was pixels on a screen. And over the years, various technologies came out with simple libraries and tools, and it was always very awkward. And as we know, engineers just want things to work. And so they'll get a button to work and the marketing person will say, it's not quite the right shade of blue, or I want it moved over a couple pixels. And the engineer's immediate reaction is, it works. Let me move on to something else that needs to work. But the reality is that, I told all my students that engineers are the people to develop user interfaces because we know too much. We always try to represent what's in the box instead of how it's used, right? And so engineers don't really want to tweak. And if you can separate the UI development from the embedded work, you can have two people working at their strengths. And we've seen tons of tools come and go for various platforms, and certainly for large OSs like Windows, Linux, there have been tools that really help when you use them in the embedded space. But for small micros and even smaller microprocessors, there hasn't been a great solution running with real-time operating systems, or even without a real-time operating system and just a simple scheduler, until we saw LVGL come out, which runs across multiple platforms.
Well, hold on, let me interrupt you there. There are lots of good interfaces, HMIs today, and you're making it sound like there aren't, or they're too hard to develop. But there are alternatives.
There are alternatives. None of them tend to cut across both MCUs and MPUs, allowing you to take the same user interface and with very little intervention, run it on a completely different platform until you get to something that really requires Linux or something underneath it.
Well, maybe that was even an unfair question to ask of you. Why don't we find an expert who really knows more about this? And we have our expert who was with us on the webinar the other day. Vin, I'll let you say his name because I'm not really good with those foreign names.
Okay, well, we have Gabor Kishvamoshi here to speak with us. So welcome, Gabor.
And he is with who, Vin? Come on, finish the intro.
He's the founder and CEO of LVGL. You can find them at lvgl.io. And this started out kind of as a pipe dream for him, trying to help out a friend. And I'll let him tell the story and how he's decided to make it as cross-platform as possible. So welcome, Gabor.
Yeah, welcome, Gabor. And explain to us what LVGL is and why it's needed.
Sure. First of all, thank you very much for having me. It's a great pleasure to have this podcast with you guys. So yeah, it's a fun story, I guess. So I was like a teenager, kind of, during the university. I had a friend. He was also called Gabor, just like me. He was the hardware guy. I was a software guy. And, we were both electrical engineers. So we were doing stuff at home, like laboratory power supplies, signal generators, all this kind of like magical stuff for ourselves, because we don't really had money to buy stuff off the shelf. So we developed these for ourselves. And, we started to wonder how great could it be to develop our own instruments and have a so-called graphical user interface on it. It wasn't so common at that time. It was like almost 15 years ago or so. Smartphones just barely appeared in the market, and you could already buy some TFT displays from eBay or so, and we really bought some. And this friend of mine, Gabor, bought a display for me, actually, and I said, if I can light up the first pixel, the rest will be easy. And actually lighting up the first pixel took only 2 hours because the vendor provided all the initialization code and everything. And since then, in the past, like 10 plus years, I'm doing the rest, which should have been easy. So yeah, it turned out that really showing something on the display is not a big deal, but creating a software with a good architecture, making it like scalable, vendor independent, performant, feature rich, is like super complicated, and it's just the first step. So once I had it internally, I published it on GitHub, then the whole thing like blew up. Contributors started to came. I started to have discussions with chip vendors. I could create my own company in 2020 because I had already some service projects to have a salary for myself at least. And another big boom happened 2 years ago when we decided to start developing a UI editor for LVGL as well. So not have it only as a C library, but but just add some tools to make the development faster and simpler.
Well, I'm a little confused. If it's available as open source on GitHub, what do we need you for?
Well, great question. So actually what you have in GitHub, or what everyone has on GitHub from LVGL is okay as it is. And that's the beauty of open source. So if someone downloads LVGL right now, they have full control. They don't really need me. They don't really need the company behind the development. They download the source code and they own it. They have full control. So still, there are a few things for which, fortunately, I'm still required. So we still need to maintain LVGL. Always there are a lot of requests from vendors, from users, new features, new integration, new optimization, new GPU support, bug fixes, obviously, a lot of things. But also we provide services. So developing LVGL is just one thing, but we also help our customers since we have grown as a company. Now we are almost 20 people, and some of them are working in our services team. So if an OEM or anyone comes requiring support or design implementation, we can take care of it.
If it makes you feel any better, I used to ask Richard Barry, who developed FreeRTOS, that same question all the time.
And what did he say?
Pretty similar, but he ended up doing pretty well because he ended up being acquired by Amazon. So that worked out quite well for him. Anyway.
Oh yeah, success story.
And I will say that some chip vendors have really gotten on board with this. Rich, you and I have talked a number of times about Renesas and their IDE and their SSP, which is their code base for providing much more than a HAL layer. And they've actually worked with LVGL to create a version that can be dragged in using the SSP right into a Renesas project in E2 Studio or in the configurator if you're using a third-party tool like VS Code or IAR or Sager.
So I'll ask that same question to you, Vin. Wouldn't it behoove a Renesas to acquire this technology to stop their competitors from having such an easy path?
Well, I mean, I suppose that move could be self-serving, but one of the powers of this tool that makes it different than others is even the open source version, which you don't have to pay for, you'd be able to use it across platforms. And so it really, in the customer base, it's valuable that they stay independent. Also, they can be making, FreeRTOS wasn't acquired in week 3 or in year 5, right? There was a ton of community work, a ton of changes, things around secure interfaces and all kinds of things like that made it get the critical mass that then made sense for somebody who wanted quick connectivity to buy. And if you remember, Microsoft bought ThreadX, and then of course now it's part of Eclipse, right? They released it out in Eclipse.
Yeah.
So it's owning something outside of your area of expertise is not for the faint of heart necessarily. I actually think that strong alliances where everyone can work in their strength area makes a lot more sense, at least early on in the genesis of a tool like this. So, I mean, Gabor, tell us, obviously the open source one, you can download it. There are function calls to say, put a pixel up, put a character up, draw a square, whatever, make a button, press on a touch if that's linked in. But you have done a bunch of stuff to make it easier than that even to define a user interface. So can you tell us a little bit more about the XML interface in LVGL Pro?
Yeah, absolutely. So LVGL itself, as you can find it on GitHub, is a C library, basically. It's a lot of C and header files that you can drop into any project. It's very flexible, easy to compile, easy to integrate. But if you want to develop a UI, it requires some serious development skills. Obviously, we want to make it as simple as possible, but still you need to be a software developer you need to write C code, calling functions like button create, set position, set size, set layout to row, add styles, events, animations. So it's C coding basically. Not so complex, but still C coding, which is great from one hand because it's quite flexible. In C, you have like infinite flexibility basically because you can code anything that you can. However, if I think about the speed of developing UIs, it's not the best, because if you need to type an API function's name and you need to do it a lot of times, it's just a lot of characters to type. Just to give you an example, if you want to set the X and Y coordinate of a button, you need to call a function like LV object set X, then LV object set Y, then LV object set width and height, and all these kind of things. A lot of characters to type. And once you type this, you still don't know what's going on. You need to compile the code and check how it looks. LVGL comes with simulators for desktop, but still needs to be compiled. It's a lot of time. So we wanted to resolve this. We wanted to make the whole UI development faster, more intuitive, more flexible. So we started to develop a UI editor tool for LVGL. We call it LVGL Pro. Actually, it's more than a UI editor because it's a set of tools to make UI development really much simpler than with LVGL, the C library only. So the editor itself, as you already mentioned, it's an XML-based editor. The structure is very similar to how an HTML web page looks like. When you create a button in XML, it's like opening bracket for XML, button, and X equals 10, Y equals 20. So it's like just so much faster to type. But as you type it, you immediately see how it looks like. On the left-hand side, you have the XML. On the right-hand side, you have the preview. It immediately saves like a ton of time. It's a 5 to 10x speed up just to create the UI. And there are other great things in it. It's a component-based solution. So it's not like you start developing just the screens. You immediately start developing components. My button, my slider, my card, my list element, my list. All this kind of stuff are components that you can also preview immediately. If you want to see how your list element looks like, you open the list element.xml and you can see it, and you can put together more and more complex components and screens from it. It also has features like UI testing, data bindings, Figma integration, because Figma is like very popular designer tool right now. We need to make sure that there's a smooth path to connect the two worlds, the design world and the development world. We can also help companies with a command line interface, CLI, to integrate all these easily and run the tests, for example, in a CI/CD workflow. You can also share your project online. So if you push your XML files to a GitHub repository, you can just open it in a browser, basically. Just select the GitHub repository that you want to see, and anyone, your manager, marketing people, customers, fellow developers can check it out without any issues, without installing any development environments.
And the XML also has definitions in it for processing button presses as well from touch, right?
Oh yeah, absolutely. The most basic thing that you can do in XML is creating a button, for example, and as a child element of the button, you can say there is an event callback where you specify, hey, when this button is called, when button is pressed or released or long pressed or whatever, call this function. This is the most simple thing that you can do. But there are a lot of built-in functionalities like load a screen, for example, change the value of a variable that might be connected to, for example, a slider's value. So you can have a plus button which increases the value of a variable, and when you press it, the slider value also moves. So there are like data binding related events as well. But yeah, event handling is part of it.
Now we haven't mentioned anything about applications. Is there a target application where you say, if you're doing X, you should definitely be using this technology? Is it automotive? Is it consumer? Is it industrial? Or is it just any place?
Wow, that's an amazing question. So LVGL itself mainly targets the IoT smart consumer market. So usually I say everything where people cannot die if something goes wrong. because if your smart home panel freezes or crashes or whatever, it's bad obviously, but it's not the end of the world. So this is the main area for LVGL, and everything there is a good target, including smart home and IoT, all this kind of stuff that I already mentioned, instruments, musical instruments as well, actually, like small dashboard for
industrial equipment also.
To some
laboratory
extent.
equipment and factory floor equipment. And
wearables are also a perfect target. There are a lot of companies, especially in China, who are using LVGL in smartwatches sold in hundreds of millions. However, we also see that with LVGL only, we can cover only half of the market, because we don't really cover the safety relevant area, the automotive, the industrial, the medical, and the avionics. So we just started to develop LVGL Safe. LVGL Safe is a much simpler UI library than LVGL, not so feature-rich, smaller code base, much smaller code base actually, but it's certifiability, if it's a word, in mind. So it's something that can be easily integrated into larger projects when there are safety critical applications, and it can be easily certified with other applications with the actual product as well.
Yeah, I'd like to dig a little bit into this XML as well. Is that only used for statically building a UI, or can you actually do something with it when the UI is running?
Well, so LVGL itself on its own, without XML, is already quite dynamic. Everything is happening runtime. There is no statically creating a UI. You can always delete items, you can always create new items. All these are happening dynamically. However, XML really pushes it to a new level, because what you can do with this new XML syntax basically is you can load the XML files at runtime without recompiling and refreshing the microcontroller. You can think of it like you create the XMLs on your computer, and instead of creating an over-the-air firmware update, you can just download the XML files via Bluetooth, Wi-Fi, load from an SD card, send via serial port or CAN or Ethernet or whatever. But the gist is that you just need to send the XML files. Once they are there, LVGL can read them and build the UI from them at runtime.
Yeah, Rich, this is funny because I was talking to a customer last week, actually, and they were saying they wanted to increase the frequency of over-the-air updates to firmware. And I'm like, what the hell are you talking about? Why would you be doing that? I mean, it's not like you can download another sensor or a capacitor. I understand doing periodic updates to cloud software or software on your PC or on your phone, because you can add new features and make new things happen. But the embedded code is typically there to support the hardware. So if you can't download a new piece of hardware, there's no reason except for bug fixes to be downloading new firmware. And a lot of people want to just make some changes to the UI, for example, right? But as you and I know, a good company will really have to test the entire code base again before releasing a new firmware release. And so if you could decouple the design of the screens with the functionality of the code base, then you could be updating screens more easily and more often if that's what you need to do, if your UI happens to be generated on the device through the embedded system. That's interesting to me, actually.
Actually, it's just one use case, because it's really useful. You don't have to update the whole firmware, it's less risky, just a few files, and you can easily restore the previous files if something goes wrong. That's handy. However, there's a bigger opportunity here, actually. It opens a wider door, I would say. Just to give you a practical example, there is a company, they are developing musical instruments, actually some effect pedals for guitars or keyboards or something like that, doesn't really matter. But that effect pedal has a display, and that effect pedal also has some plugins. What kind of effects you want to use, in which order. You can change the position and sequence on the display. But they were thinking about making it more community developed and more flexible from the end user point of view. So they wanted to come up with a plugin store for the effect pedal. Obviously, it requires some like audio signal processing stuff as well and functionality, but also requires UI. So we started to play with the idea of having an online store of some kind of online editing experience where you can put together plugins and these kind of things, the UI as well, and then you can add all these to the screen or to the actual product, all these dynamically. And the big opportunity that it opens is now you can easily make your end customers take care of the UI themselves. And then publish applications, for example, and anyone can download them easily.
Did
That's
we
great.
talk about the memory footprint that's required and how that would compare to other techniques?
Oh, absolutely not substantial. Parsing those XML files is not a big deal. These are usually small. One XML file is maybe 1 kilobyte or 2. Parsing it is very light. And once you create those widgets, after parsing the XMLs, it's all in LVGL's memory. So it's the same thing as if it were created with normal C code.
So what's a typical, if I had a user interface that was, let's say, I don't know, so 480 by 320 or something, or 240, 480 by 240, reasonable aspect ratio, and I had maybe a half a dozen widgets on each screen, and I had 4 screens. What would you say the flash and RAM footprint would be for that?
Well, the RAM is easier to say because you need to store only the LVGL widgets in RAM, and it's a few tens of kilobytes. Obviously, if you have a list with 2,000 contacts or something, it will take some extra memory, but normally for a typical UIs, it's not a big deal. It's a few tens of kilobytes of RAM for LVGL's word memory. Of course, you have a frame buffer, which might be in the microcontroller's memory or external RAM, or in an external display controller. And in that case, you communicate with that external display controller via SPI. In this case, you need only a smaller, we call it partial frame buffer for LVGL to render into. But normally the RAM is not a problem. The flash size depends on actually what you need in the UI. If you have a lot of images, they take flash. We can compress the images, we support a lot of color formats, but there is no black magic here. To store assets, you need flash.
Right. So let's say, obviously images are bitmapped and they could take a lot of space. But let's say we just have a couple of sliders, a couple of buttons, and a numeric display. Those widgets, what do the widgets themselves take in space?
Oh, okay. So in that case, if you don't use huge wallpapers and a ton of icons or so,
Right.
Mostly, in most of the cases, you can go without images or very small icons. In this case, the flash usage is like very minimal. You need maybe 200K for LVGL flash, and you can make it smaller if you disable some features. But I think 200K is safe. To create the actual screens, it's not a big deal. It's, let's say, 10, 20K just for the C code to create the buttons and labels. For RAM, maybe 30, 40, 50K of RAM, and the frame buffer depending on your hardware configuration.
So Rich, a lot of our listeners who are used to writing code that takes 6 or 8K of RAM with a C stack and less than 64K of code space, these sound like really big numbers to them.
Mm-hmm.
But those are typically applications that have very simple UIs, switches, lights, a couple of knobs or buttons, maybe a 7-segment display or a small character display. When you get into graphic stuff, the size of the memory gets really, really large really quickly. So this is something that our listeners really need to think about as they adopt touch screens or graphic displays. If you're using a monochrome display, the footprint is less because you can pack the pixels in. But if you've got color displays, then you've really got 2 bytes to 3 bytes per pixel. And if you have a high density display, that number gets pretty big. And you're either moving into MCUs with external RAM or very smart displays that have all the buffer space in the display, and you're talking to it quickly bidirectionally with SPI, or you're moving into MPU territory. And I think it's interesting because, you know, as you and I have talked, the MPU space is really in 2 pieces. There's the piece that's running Linux or VxWorks or some kind of, you know, larger OS. And then there are people who are running ThreadX and FreeRTOS on an MPU. And especially for those people, they don't have the ability to use some of these, you know, quote unquote desktop graphic packages to create their screens. And so something like this is very valuable to them to look into, especially with the acceleration that Governor now has created with the XML and the drag and drop interface.
That's very true. Actually, the whole MPU space, it seems it's less straightforward than it was, because, yeah, maybe 10 years ago, it was just Linux. There was a shorter time when Windows also had an embedded solution, but I think it's closed officially right now.
It's closed officially, yes.
Yeah, but anyways, it was mostly Linux, and this whole running an RTOS on MPU thing is pretty new. At least I didn't really hear much about it 5 years ago or so.
Yep.
And it's really happening. And it seems like ARM is also taking steps into this direction with a new core called Cortex A320, I think, which is like a microcontroller-ish speed and power, but it's still an MPU, and you can also run Linux. It's clearly to be somewhere in between the two worlds so that you can easily change or decide what you want.
Very good.
Yeah.
Well, this certainly puts into context all the things that we talked about on the webinar the other day. Looks like a no-brainer to me.
Yeah, it's you know, it's easy to download and play with. A number of companies, including Renesas, have kits that already have LVGL running on it. On LVGL.io, there are sample projects for a number of processors, including the Renesas RA6M3, I believe, if that's correct, and the new RA8, and other processor families from other semiconductor companies as well. So depending on what family you're working with, it's certainly worth grabbing a board from Mouser or DigiKey or whoever your favorite distributor is, and downloading the free code and playing with it and seeing how it works.
Absolutely.
Oh, yeah, actually, I can confirm that. Fortunately, we don't have issues with scalability from MCUs to MPUs, and this because the core LVGL library is really nothing else in its heart than, I don't know, 100C and 100 header files. You can just drop it anywhere, and if you can compile it, then LVGL is integrated. Once it's running, it will give you a buffer where the image is rendered, and you can decide how to send it to the display. That's all what you need to do for integration. So yeah,
right.
And it's small enough to run on MCUs.
Yeah, we didn't really say this explicitly, but it's implied that if you're defining your UI in XML, then it's scalable from the smallest processor this will run on to the biggest processor. And assuming the screen is relatively the same aspect ratio, you're going to get basically the same UI as you migrate your product through the different power levels inside a product line, or even across product lines, right? So that's a pretty exciting thing.
Oh, that's true, but it's true without XML as well. So once you have an XML C code base, then it runs, the very same code base runs on a microcontroller and on a microprocessor as well. Maybe you just need to disable whatever display driver you had on the microcontroller and need to enable Wayland instead for Linux, for example. And that's it, all built into LVGL. But I think XML opens another important door, and this is what I already mentioned. It's basically thinking in components. So once you can create components, you can also create a component library for yourself. And this component library can consist of like items like my button, my slider, my heading 1, my heading 2, my heading 3, my dropdown, my everything. So you can have it all for your company, branded, all the logic is integrated, and you can just push it into a GitHub repository. And when you need to develop the new product, which will use the very similar components, just maybe different screen, just maybe, different display size. We call display the physical hardware and screen is the virtual thing that is in LVGL. So maybe you will have a different display size, and maybe you will have 2 more screens, but not a big difference because it's the same product line. You can just reuse the same component library, just add it as a submodule in your new project and start reusing my button, my label, my whatever.
That's great. Well, thanks very much for joining us and talking through these details with us. I hope that our listenership finds this interesting and that they download it and play with it. And they can find you and your company at lvgl.io, correct?
Exactly. Yeah, lvgl.io is the main website that we have. And from there, you will find all the links to services and LVGL Pro and all the things that we have discussed.
Awesome.
And the link to the GitHub is there as well, right?
Oh, of course. Yeah, that's the most important
Yes,
thing.
okay, all right, great. Thank you very much.
Yeah, thank you too. The pleasure was all mine.
Now, here's Rich and Axel Sikora of the Embedded World Technical Committee.
Good afternoon. My name is Rich Nass. I'm with Embedded Computing Design. I'm here this week with a very timely guest, Axel Sikora, who is the conference chairman for Embedded World. How you doing, Axel?
I'm fine, thanks, and thanks for reaching out.
I'm actually a little surprised you had time for me this week. We're only a few days before the biggest week of the year as far as Embedded World is happening. You must be pulling your hair out and going crazy, I would think.
The advantage is I don't have any more hair left, you know. No, but indeed it's quite busy, but it's of course also important to let people know what we are doing and trying to make Embedded World even more attractive.
And I guess if it isn't done by now, it isn't getting done at this point.
Yeah, absolutely.
So before we get into Embedded World, I want to make sure people know who you are. I said you're the conference chairman, but you're way more than that. So just on the Embedded World side, what are your responsibilities?
Well, basically, I'm staying on both legs. As you know, Embedded World is Embedded World Exhibition and Conference, and as you said, I'm chairman of the conference since 7 years now. And in parallel, I'm also speaker of the advisory board to the Embedded World Exhibition. So looking after both sites and trying to pull them also together.
And you only do this for fun because you actually have a full-time job outside of Embedded World, right?
Yes, full-time job is being a professor at Offenburg University, where I'm leading the Institute of Reliable Embedded Systems in Communication Electronics. So doing a lot of research about real-time, secure, wireless communication, and making my hands dirty. And therefore, it's also very good fun to be at Embedded World and leave our ivory tower, well, which already has some doors and windows, and get the smell of the global world. Yes.
Very good, very good. So Embedded World. Why don't we start with the keynote? Who do we have delivering the keynote address?
Keynote this year will be held by Rich Remoncic, who is CEO of Microchip Technologies. Title of his speech will be Learning from the Octopus, Nature's Blueprint for Intelligence Everywhere. So Octopus having a lot of distributed edge AI in its tentacles, and that's its a metaphor for the distributed intelligence that we currently see in many IoT systems.
Now, we talk about artificial intelligence pretty much every conversation I have with people in the industry. I assume it's the same with Embedded World. We're bringing artificial intelligence into the conference in a huge way, I would imagine.
Yes, absolutely. I mean, Embedded World really is a game changer, not only in the big world, in the world of the supercomputers, high performance computing, but also in the edge AI. So changing from static systems to adaptive systems, changing from smart systems to intelligent systems, and and also making systems less predictable as a challenge. And as this is a game changer, helps to increase efficiency, helps to increase performance, but on the other side also includes risk. So there's a lot of things to discuss.
Now, I know with a lot of these events, especially one that's as established as Embedded World, you probably get way more submissions than you could possibly use. Is that the case here? And what is the process of culling them down to the best of the best?
Yeah, indeed. We already have a huge program, 218 hours of program in 3 days. So that's pretty dense. Nevertheless, in total, we got more than 600 submissions and selected below 50%, which is, I believe, a really low rate for such an industrial-driven conference. And we are, from year to year, we are happy that people continue to submit because, well, we academics, we know that it's usual to be disregarded, but for industrial people, it's maybe not so much used, and therefore we are very happy to get a continued stream of so many submissions. The process is very straightforward. People do their submissions until end of September. Then we have a program committee of around 50 persons, renowned persons, mostly from applied research, who are doing a pre-selection. Then we sit together 2 closed days with our steering board and compile the program. So it's 2-stage process, and compile a program of 81 sessions, 5 panels, 20 classes. So it's a lot of stuff to be organized, and always a challenge for all our brains, I can say.
Is there anything that's very different from last year to this year?
Yes and no. No, in that sense that we believe that the model of the last year or the last years has been very successful. So having all our different tracks around the major topics, IoT and connectivity, embedded OS, safety and security, you name it. Edge AI, of course, I shouldn't forget. For this year, and this has been well proven, I believe, and very much also supported by audience. In addition to the normal sessions, we introduced a couple of years ago panel discussions at the end of each session. That means after each 3 presentations, we have a panel discussion with the 3 speakers, which typically is very lively and keeps many people from going to the coffee break or the lunch break, but staying in the room, which is good, of course. For this year, we, for the first time, have a application track, use case track. Up to now, Embedded World has been technology-driven only, but we felt that talking more about applications absolutely makes sense because there are so many vertical dependencies, number one. And number two, as you may know, we became more international. We had North America event, or 2 North America events. Better to say we had 3 Chinese events, and especially from the Chinese events, we've understood that these application tracks, these use case tracks are extremely important and can be very attractive.
Yeah, I could certainly see the reason for that. For better or worse, embedded technology doesn't move that quickly. And I say better because it has to be proven. You certainly don't want to put something out in the embedded space from a technology perspective that you're not sure isn't going to work all the time, every time. So for that reason, in my opinion, the technology tends to move very slowly. So when you do look at these application issues, they can point out the places where it does make sense to follow their designs. Hey, this worked really well. You may want to implement this in your design. Hey, this part is very challenging. You might want to be careful if you plan to implement this. Am I looking at this from the right perspective?
The result would be the same, but I would use a different argument. Number one, for me, technology is not moving so slowly. This might look to you because you're not working as an engineer. Second reason is, indeed, we, of course, have a lot of vertical events already. So there are automotive events, there are industrial events, and therefore we need to be careful not to compete too much against that, but keep our horizontal view as a main view. But the outcome is identical to what you said.
Yeah, and to be fair, my point of reference was comparing to something like consumer technology, where every few months there's a new generation of a device. Whereas in the embedded space, it might be once a year where a new revision rolls out. That was really what I was referring to.
Yeah, it always can be faster. That's absolutely true. I mean, we also should be clean in that sense that also in those spaces where speed seems to be higher, it's not always major revisions, but also can be minor updates, just scalability, so to say, which is difficult enough. Don't get me wrong. But if we look into the large part of our world, which is still analog, we are still moving at a rapid pace, no doubt.
Very fair. And the other piece of this discussion that we didn't even mention that has a lot to do with the speed is the security. You can't roll out a product that you're not sure is 100% secure. And that's another reason why we just need to go at the proper pace.
I don't like to say that something that you made a wrong statement, but nothing is 100% secure. Number one, you can't measure security. Number two, nothing is 100% secure. We need to find a reasonable compromise between the efforts and the result. Obviously, currently, security is a second hot topic together with embedded AI, both driven by global events and global endangerment. And of course, also driven by legal requirements. On the European side, we have the Cyber Resilience Act, which poses or imposes significant load onto the companies, and everybody, and I really can say everybody, is pretty nervous about introducing the security conformant to the Cyber Resilience Act, and of course also looking very nervous into the reviews that will be done. So currently it's a very hot topic, very important, both for real reasons and for legal reasons, which of course are also real.
Very good. Well, thank you very much, Axel. I don't want to keep you any longer. I know how busy you are this week, and I look forward to seeing you next week.
Yeah, see you, Rich. Fine.
That was Axel Sikora. He is the chairman of the Embedded World Technical Conference, and I'm Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.